Let's go on. All right. Once we had done the spectroscopy, and I did this for like 6-7 months, did all sorts of analysis with Ziggy. Ziggy became very arrogant. He said, look at what I can do. I can prove that these elements exist. I'm going to be famous. And so he goes over to Germany and he talks to all his spectroscopical friends. And there was actually articles written in magazines about him over in Germany that he had discovered that these naturally occurring platinum metals were in Arizona. But he never could find anything that would analyze anywhere close to what he had analyzed for me. He analyzed the best material he found with analyzing 10 to 12 ounces per ton. Okay, mine was like 2,900 ounces per ton. Okay, big difference. Anyway, he said, Dave, you know, I'm going to work, I'm going to take this, I'm going to promote with it, I'm going to raise money. He went up to the Las Vegas area and worked with some people up there in Nevada. And then after working with the people in Nevada, I heard the information and moved up to Oregon, Washington area. I mean, it's just amazing how like spiderwebbed out the information after he started promoting with it. Unfortunately, Siegfried Brimmer has died and he isn't with us anymore, but it's part of my history, so I'm giving you. One of the problems we had, and I really can't be more specific, I want you to understand this, is the procedure according to the Soviet Academy of Sciences, the Vernadsky Institute for Precious Metal Research, that when you get the elements separated, you do a hydroxide precipitation, you drop it out of solution as a hydroxide, you filter it, water wash it, then you put this into a tube furnace. And a tube furnace is actually a quartz tube, glass tube, and it can be, you know, this size to this size, but the tube goes through a furnace that has a round opening in it. And you actually put the tube inside the furnace, then you take this little porcelain boat, or some people use metal boats, put the powder that you've just taken out of the solution, you put it in this boat, you take a little metal push and you push the boat into the center of the furnace, where it's in the heating zone. You put a stopper in the end of the tube, and then you hook up a glass line and then a rubber hose that brings oxygen, argon, hydrogen, whatever gas you want. Well, according to the Soviet Academy of Sciences, you heat it under oxygen up to 800 degrees, and it forms an oxide. And then you put an inert gas in there, usually argon, to get all the oxygen out, and then you put hydrogen in. And then you hydroreduce it for 15 to 20 minutes, and then you cool it down under hydrogen if you want a hydrogen compound, but if you want all the hydrogen out, you cool it under an inert gas like argon or helium. You cool down the ambient temperature, then you reach in and take the cork out, reach in and pull a sample out, and you put it on a scale and weigh it. Okay, we did this. We have a little digital scale that weighs down to micrograms. And we put it on a scale. But the weight of the scale, just said the numbers are just running like this, like a slot machine. And John says to me, Dave, when do I record the weight? Now? Now? And you know, this is just driving this PhD crazy. He said, Dave, this makes no sense. Well, if you actually take the sample and put it under a stereoscope, a microscope, you know, three-dimensional microscope, you actually can see that, and it's actually forming crystals and growing right here in front of your eyes. And what it is the element is so reactive that it reacts with the air. And so it's pulling oxygen and water and nitrogen out of the air and growing crystals right here before your eyes. And John says, you know, Dave, we have to get the real world. This is just like an approximation. This is not science. And yet we're following the procedure we're supposed to be following, right?
Did you see any pyramid-shaped crystals?
I've seen more octagon-shaped crystals than you can ever imagine. Anyway, there's every shape in there because there's all the elements were in there, and depending on the element you're working with is what the shape was. But it was very reactive is the point, people. And it's continuous. It continues on and on and on and on for an hour, 2 hours, 3 hours. The color is still changing. And so you really get frustrated. And I said, John, now this is after months of this, Every day we'd try weighing some of it. Now you can imagine the frustration. I've tried to do good, solid science, and I said, there's got to be a real world here someplace. He said, Dave, there is an instrument. There's an instrument available commercially that was developed for the aerospace industry. It's called thermogravimetric analysis. And this machine actually is made out of a glass tube, a Pyrex tube, but inside the tube it has a heating element, and actually has a coil, and it has a little balance scale inside the heating area where you can put a sample in there under a controlled atmosphere. You could oxidize it, hydroreduce it, put inert gas on it, whatever you want, and it never hits the atmosphere. I said, at least we will learn what it really is when we hydrogen reduce it, right? How much does it cost? Well, they're about $350,000. And I said, well, I'll tell you what, can we lease them? And he says, yeah, you can actually go to PerkinElmer and they'll lease one to you by the month. And I said, well, let's lease one. I'll bring it in. So we brought this thermogravimetric analysis machine in, and John actually hired a master's chemist from England that had specialized in operating analytical equipment and instrumentation, because this machine was all computer controlled. So this lady came in, I can't remember her name right. I think it was Jan something, but I can't remember her last name. Anyway, she came in to run the TGA. Now when you lease this TGA, they actually give you analytical standards that you can actually put in the machine and check the machine with these standards. And they tell you exactly at what time, what temperature and the compound will begin to break down, and what the weight change should be, and then at what higher temperature it continues to break down and what the weight change will be, and you put the standard in to check the machine. And we put standards in, checked the machine, and everything worked really beautiful. So then we actually used the empty pan, we ran it to see, and everything went, it's just nothing changed, it always just stayed constant temperature. So then we put, and this was actually an iridium sample, and this is actually the transparency I used last time I spoke. But this is an iridium sample. There was 10.55 milligrams, which is not a big sample, it's a relatively small amount of material on the boat, and we started heating it. Now down here at the bottom is the temperature, and it goes up to about, what, 850 degrees approximately. Now this is going from 100% down to like 60, what? That's 75, 50, that's about 60 something percent, 55 to 60%, just in the first heating. Now people, I can't explain this weight change when it was occurring. This was a dramatic weight change under an inert gas.